Right. Get it. Into referral. Grade 9. Theorem of Pythagoras. Right. Theorem of Pythagoras. In any triangle where we have one angle that is equals to 90 degrees. Now you can be given a figure or a triangle. What you get A, B, C. What you wanna get 3 centimeter, what you wanna get 4 centimeter, what you wanna find the value of x. In a right angled triangle, then I lay the adjacent side, the opposite side, and the side which we call the hypotenuse. Yeah? So the hypotenuse is the longest side in your right angled triangle. Right. So if you were to find the value of x, which we call the hypotenuse, you will use what we call the theorem of Pythagoras. Every x squared plus y squared equals the hypotenuse squared. So the adjacent side, that is a squared, plus the opposite side, that is a squared, will give you the size of the hypotenuse, which is also squared. Okay? Yes. So we can say our x is BC, that is a squared. We can say our opposite is AB, that is also squared, and our hypotenuse will be AC, that is also squared. And then we can substitute the values. It is very important that you note that the SI units has to be the same, or the units of measurement has to be the same, centimeter by centimeter. If the units are not provided as being the same, then you will need to convert. Okay? Yes. So we can have the values to say, okay, this is 4 centimeters squared, this is 3 centimeters squared, and this is your AC, that is a squared. 4 squared is 16 centimeter squared. 3 squared is 9 centimeter, that is a squared, and this is your AC squared. Now 16 plus 9 should be 25 centimeter, that is also squared. Now remember, I'm looking for the value of AC, not AC squared. Then you will introduce the square root on both sides. Yeah? Yes. So you will say, okay, square root and square root. The square root, 2 and the root will cancel one another, because you have 2 times 1/2, which is 1. So your AC will be the root of 25, which is 5 centimeters. So that becomes the value of x. And it should be the longest side, again, because it is the hypotenuse. So this is one practical example of how you should apply this theorem of Pythagoras. And then we can have another problem. We can say A, B, C, and D. And we can say find x. We can give you the value here as 3 centimeters, 4 centimeters. We can give you the side here as maybe 5 centimeters. And we say to you, find the value of x. Can you find x? Okay, let me give you some chance. Let me just pause the tutorial. The same answers or not. Now, first of all, when a problem of this nature is presented before me, is to analyze the situation. I can see a triangle in here. Before I can get to the value of x, in this triangle, there's one side that is missing. I need to find this side. Because when I have this side and I have this one, I can be able to find x. Okay? So how do I find that side? I will say, all right, I know that theorem of Pythagoras will tell me that AD that is the squared, plus GB, that is the squared, must be equals to AB, that is squared. Okay? Theorem of Pythagoras. Sum of the two sides.
First of all, before all we had calculations on, you have to include which triangle are you working on?
A. I did. I am on this triangle. Hence I'm saying AD plus BD equals AB squared. So I'm indicating to say I'm working with this one first. Again? A sharp. Yeah, I have indicated. Or when how did you indicate when
first of all, as I was writing in triangle ABD. That's what I wrote first.
Okay, you said in
Triangle.
okay, let's use a black one or even blue. Also in triangle ABD, okay. And then you will say AD squared plus BD squared equals AB squared. Okay. AD is 3 centimeter that are squared, and then you have your BD. This is the unknown, but also squared, and you have your AB, which is 5 centimeter that is squared. Okay. And then 3 squared, that would be 9 centimeter squared, BD squared, and 25 centimeter squared. And then from here, we'll say BD squared equals 25 centimeter squared minus 9 centimeter squared. What is 25 minus 9? 16. 16 centimeters squared. And then I'm looking for the value of BD. I will square both sides to say that BD equals 4 centimeters. Now that I have 4 centimeters, it becomes easier to find X. Okay?
Yes.
We've found X.
Yeah, I didn't, because my time was up.
Okay.
I was about to ask this question. Is it possible that two sides are equal?
In this case, yes, it's possible. The adjacent and the opposite are equal. Yes, it's highly and highly possible. So here I will also say in triangle BCD. Again,
yes,
if we follow the alphabetical order. Again,
yes,
and then I will say okay, DC squared plus BD squared would be equals to BC squared. Again,
yes.
And then my DC or CD, let me say CD, that would be 4 centimeter squared. BD, that would be also 4 centimeters squared. That is BC, which is X squared. And then this would be 16 centimeter by 16. Again, what is 16 plus 16? 32. 32 centimeters squared equals X squared. Again, and then from here I will square both sides. And 32, is it not? Is it a perfect square?
It is.
The square root of 32, you guys.
I'm not sure. I could see.
I don't think it is a perfect square. Let's just say 32, the root of 32 centimeter equals X. That becomes the value of X. But we know it has to be a value greater than 4. Okay? 4 point something or whatever. Because the square root of 36 is 6, so 32 is not a perfect square. So that becomes the value of X. Okay? I can say right, let me give you the last one before we can call it a day. Suppose you have something of this nature. You are given the value, it's 3 centimeter. You are given the value is 4 centimeter. This is x. You are given the value is 6 centimeter. Find the values of x and y. Find the values of x and y. If we will find the same answers. Now, to find x, I think it becomes very easy because you having BC squared plus AB squared, that is equals to AC squared. So your BC is 3 centimeters squared, AB it's your x squared, and your AC is 4 centimeter squared. So 3 squared, it's 9 centimeters squared, and you have 16 centimeters squared. Take to the other side, your x squared becomes 16 minus 9.
8. Yeah? Yeah, 8.
16 minus 9. You get 8 centimeter squared. We're looking for x. Our x is the root of 8 centimeters. Okay? Because 8 is not a perfect square, or you can write this as 2 root 2. Because two numbers, when you multiply them, they give you 8. It's 4 and 2. One of them should be a perfect square, which is the root of 4 is 2. So you end up with an answer of 2 root 2 centimeter as the value of x. And now that you have x, you are looking for y. You are provided with the hypotenuse, because this is the side that the angle of 90 points to. So in this triangle, you have the hypotenuse, which is 4, and this becomes impossible. Again, there's no way that this side can be bigger than the hypotenuse. It's highly and highly impossible. So let's just say the number there, it's a 3. Let's just say the number there, it's 3, because it is virtually impossible for them. So we will say I have it doesn't really matter here which one is x, which one is y, but we can say AD squared plus CD squared equals AC squared. Okay?
Yes, sir.
I have my AD, which is 3 centimeter squared. My CD is y squared, and my AC is 4 centimeter squared. I have 9 centimeters squared, y squared 16 centimeters squared. Y squared equals 8 centimeters squared. Y equals 2 root 2 centimeters. So the value of x and the value of y are the same in this case. In this case, after we have modified the problem. So this will bring us to the end of our lecture for today. And then we shall continue and see what is happening. We're going to look at the previous question paper last year and see how we can work around this and